This is a continuation of the last video where we went from coreboot, which loads the payload SeaBIOS, and then once SeaBIOS is loaded, it starts running its software, and its last step is to boot a hard disk, a floppy disk, whatever that happens to be. But in this case, instead of booting a hard disk, we're going to actually boot off a coreboot file system, which will be GRUB 2. So if I can handle it, maybe you can handle it. We'll go through it slowly enough to keep track of what's going on. Entry ELF. This is the very start of SeaBIOS. Remember, that's not C as in capital C, but SEA BIOS. These were the initializations that we talked about before. We set up all the data segments and stack segments. Then we jumped to a function called handle post in this file. There is handle post where we do a little bit of setup initialization, make BIOS writable, and we do this do POST, which is power on self test. Power on self test. Do some different things here. Nothing big deal. Coreboot pre-init, so it's aware of coreboot. Now we're into new stuff. Do post, where we do some things. Let's see if anything. We're allocating memory, and then we relocate our pre-init to this function called main init. Here's the main setup code. Interface init. Remember, this is all the stuff for BIOS. This is a final hardware setup. And one of the things that we do set up is the interrupt vector table, so that, which is the interrupts are the basic input and output systems, the BIOS. Platform. Here's we set up the VGA console, so that we can actually watch stuff happen when those things happen. Let's see, option ROM. And finally, we do the start boot. Now, the start boot is going to be one of different things, and one of those things is to load a coreboot file system. Here is start boot. We set some memory. We print this out, jump to init, so that'll go out on the screen. Set up some memory, and then we do a function called call 16 init, and then hex 19. Hex 19 is the boot interrupt vector. Interrupt 19 hex bootload service entry point. Here's handle 19. Debug enter. Boot sequence equals 0, and then do boot. Here's do boot. And if we go down through here, we see that there's a sequence number to the boot. Do boot has different types of boots that it can do. One could be the floppy disk, one could be the hard disk, one could be a CD-ROM, and one of those, this is the one we're interested in, is IPL type cbfs. cbfs stands for coreboot file system. So now we boot coreboot file system. Here's the code booting from a coreboot file system payload. Now, what's that payload? Do you remember? The payload is going to be GRUB2, or just GRUB, Grand Unified Bootloader. So we have the menu and all the different features that bootloader has. Now it says booting from cbfs, and we do this cbfs run payload. cbfs run payload. What do we have going on here? We have various things that happen. In other words, the payload doesn't have to be grub, but it is in this case because that's what we've selected. The case that we're interested in, the case that's given in our header, see there's a header that goes along with that payload, is payload segment entry. And this is where we run grub. And that's another whole topic. That concludes this one. Probably could have put part 7 and part 6 together, but I made them separate. What is the takeaway from all this? Well, the takeaway from all this is that SeaBIOS sets up the interrupt vector table for all the different I/O interrupts that the system wants to use. So the operating system can take advantage of the I/O connecting software that's available here. And then finally, the booting on coreboot, booting on GRUB 2 allows us to load that in from a coreboot file system file and then run that. So it gives us the options of the operating system that we want to run, because GRUB2 will actually be the access to the hard disk to load the operating system.